So we have an interesting looking integral here, and your instinct straight away might be to jump in and notice that if we differentiate the denominator here, we get the numerator. So surely we can use the log bottom technique, as it might be referred to, which a common integral result we get that if the numerator is the derivative of the denominator, the integral is equal to the natural logarithm of the denominator, the modulus of the denominator, that is. So we have to be careful here. We have to look at the limits first. The limits of this integral go from 1 to -1, and we have to check that every single point, including those limits and in between, are allowed values for this integral. And if we plug in x is equal to 0, we get on the bottom e to the 0, which is 1, minus 1, which is 0. So we've got a division by 0 there. And that means that this is what we call an indefinite integral. The way we deal with this particular case is we separate the integral out. So we're going to write this as an integral from 1 to a, say, of e to the x over e to the x minus 1 dx, plus the integral from a to minus 1 of the same integral. And what we're going to do then is take the limit, and I'll just squeeze this in as a tends to 0. Okay, because it's not defined at 0, but we can take these limits, and we'll look more precisely at indefinite integrals in upcoming videos, but that's the technique we're going to apply here. And we're not actually sure yet whether this limit exists or not, and if it doesn't, we just say this integral doesn't exist. Okay, and if it does converge to some real number, then that's the value of our indefinite integral. So this is then equal to the limit as a tends to 0, and just integrating this in the normal way, we're going to get ln e to the x minus 1 1a plus the limit as a tends to 0 of, and again we get the same thing, but now we have limits from a to -1. But we can see as we sub in to check the limits, we get then a is equal to a, so we have e to the a minus 1, and then as a tends to 0, we essentially get that ln e to the a minus 1 tends to ln 0, which doesn't exist, so this integral diverges. Okay, so this is just an example of where when we've got limits we need to double check that our integral is actually valid in this region, and not just jump straight into techniques we've seen and copy other examples. If you enjoy integrals like this or videos on integrals like this, please be sure to let me know in the comment and any other maths content you would like to see on this channel. But for now, that is it. Thank you very much for watching, and I hope to see you in the next one.